Lesson 10.6, Modeling with Trigonometric Functions. Trigonometric functions are periodic, which means they repeat. And so that makes them useful for modeling oscillating motions or repeated patterns. Oscillating is up and down and up and down. Oh, wait. Or back and forth, but that's sine or cosine. The period is the time it takes for one complete cycle, and its unit would be seconds per cycle, or just seconds. The frequency is the cycles per 1 second, and its unit would be cycles per second, or a hertz. They are simply reciprocals of each other. Period is 1 over f, or f is 1 over the period. There's reciprocals. So let's find the frequency of y equals 2 cosine 3x. Well, here's the a, so a is 2, but that's the amplitude. I'm not sure that's going to affect anything. But that's the b, so our b is 3. Remember, the period for cosine is 2 pi over b. In this case, it's 2 pi over 3. Frequency is 1 over the period, so 1 divided by 2 pi over 3. Well, you divide a fraction by multiplying by the reciprocal. So it would be 3 over 2 pi. Why don't you pause this and try number 3? You're done. The frequency should be 3 over 2. All right, so how do you write a trigonometric model? Well, first of all, you have to know the amplitude. That was A. Then you have to define the period. The period was 2 pi over b for sine, cosine, cosecant, and secant. Most of what we're doing will just be sine and cosine. If it's tangent, though, the period is just pi over b. That was tangent or cotangent. If the situation starts at 0, you're going to use sine. If it starts increasing, it's a positive sign. If it starts decreasing, so it's going, then it's a negative sign. If the situation starts at a maximum or a minimum, you're going to use cosine. If it starts at a maximum, you'd use positive cosine. If it starts at a minimum, you'd use a negative cosine. So we're not doing cosecant or secant or tangent or cotangent. We're just doing sine or cosine today. An audiometer produces a pure tone with frequency of 1,000 hertz. The maximum, so that's frequency. So we know our frequency is 1,000 hertz. And remember, a period is 1 over f, right? So a period would be 1 over 1,000. The maximum pressure produced at the tone is 20 millipascals. All right, that's the maximum, right? So that means our amplitude is 20 millipascals. Write a sine model that gives the pressure as a function of time. All right, so they told us it's sine. Essentially, we're doing that. So I know A is 20, but I need to find B. So I can get that from my period. Period is 2 pi over B, but I know that that's 1 over 1,000. If I cross multiply, it's 2,000 pi. They want it as a function of time, so instead of x, we'll use a t. So what did we do? We found A from the problem. we use the frequency to find the period, and then that period to find b, then plugged it in. Why don't you pause this and try number 9? If you did it correctly, your answer should be y equals 0.02 sine of 40 pi t. All right, so write a function for the sinusoidal. This means it's a sine type function, sine or cosine. As you can see, the midline is not the x-axis this time. So maybe we should start by finding the midline. That way we could find our amplitude. So our midline is going to be halfway between the maximum and the minimum. So we'll average those. So the maximum's 13, the minimum's -5. So that's 8 over 2, or 4. So our midline is y equals 4. So we're counting by 2s, so the midline is right there. So our A is our amplitude. If I'm going to 4 and it goes up to 13, appears to be 9 for the A. And then our period. Period is 2 pi over b, but what is it on our graph? So we start here at a maximum, go all the way down, so that's our down, and then back up to the maximum, so that's one full cycle. It's the up and the down, so that appears to be pi over 4. Cross multiply. B appears to be 8. All right, so it's y equals a, should I use sine or cosine? That's right, it starts at a maximum, so we're going to use cosine. Okay, that's our whole function from a couple lessons back. Fill in the A, the B. There was no h, we're not shifted sideways, so h is 0. And then the k is our midline. So we usually write it as 9 cosine of 8x plus 4. Put parentheses around the 8x. Why don't you pause this and try number 11? If you did it correctly, you should end up with y equals 3 sine of 2x. Let's try a word problem. 2 people swing jump ropes. The highest point at the middle of each rope is 80 inches above the ground, and the lowest point is 2 inches above the ground. So our max is at 80, and our minimum is at 2. We could probably find our midline. So that would be the maximum plus the minimum over 2, or 41. It's halfway in between the 80 and the 2. So our amplitude would be the difference between the 80 and the 41. So our amplitude appears to be 39. It continues here. Each rope makes 2 revolutions per second. All right. 2 revolutions per second. So that sounds like a frequency is 2. Well, we can use that to find our period. Our period is 1 over f. So our period is 1 over 2. But that is also 2 pi over b. So if we cross multiply, b is 4 pi. All right, continuing on. Write a model for the height of one of the ropes as a function of time, given that the rope is at its lowest point when t equals 0. So we're going to start at our minimum, which means it's going to be a negative cosine. All right, so it'll be a negative, and our amplitude was 39. Our b is 4 pi. H is nothing. Use t instead of x. And k was, what was k? What was our midline? 41. So negative 39 cosine of 4 pi t plus 41. Let's try another example. Here the tables show the average monthly low temperatures in degrees Fahrenheit in Erie, Pennsylvania, where t equals 1 represents January. Write a model D that gives as a function of t and interpret the period of its graph. Use technology. All right, so if you have a TI 84, you go to Stat, Edit, and enter your points. And then you'll hit Stat, go to Calc, and you'll want to do a sine regression, because this is going to look something like a sine curve. If you have the numWorks, you go to Regression App, and in the data, you enter your points. And then in the graph, you'll have to change your regression to a trig regression. So here's my calculator. I'm going to go to, I have the numWorks, I'm going to go to regression. I've already entered all my data. I'm going to go to graph. You can see by the points there, it looks like a sine curve. I'm going to hit OK, change my regression to trigonometric, and there's a nice fit. Now, for this to work, it must be in radian mode. Radian mode. You have to be in radian mode. All right, y equals a, which appears to be 21.3, sine b is 0.52, x, but we're using t, plus c, which is actually a minus 2.27, and then it's plus d, plus 41.9. All right, now we are supposed to interpret the period of the graph. Well, b is 0.52, so the period is 2 pi over b, which would be 2 pi over 0.52. Okay, so I'm going to go home. 2 pi divided by 0.52 is approximately 12. Now, why does that make sense? There are 12 months in a year, and this is going to repeat every year, so it makes sense for the period to be 12 months. Why don't you pause this and try number 19? You're done. The answer should be D equals 22.90 sine 0.542t minus 2.25 plus 80.9.